Hi everyone, in this video we'll look at state minimization for DFA. Our aim in state minimization is given a DFA, we want to get rid of all unnecessary states and we want a DFA with as few states as possible. So once again, let's first intuitively understand how we are going to do this, and in the next video we'll look at an algorithm to do state minimization, a formal algorithm. So the first thing we need to do in state minimization is to get rid of all unreachable states. So let's say I have a DFA which is something like this. So on 0, this goes to Q1 and stays at itself on 1. And Q1 is, let's say, my final state. And from Q1 it just stays at itself on 0 and goes back on a 1. And then I have another state Q2 from where we go to Q1 on a 0 and Q0 on a 1. Now in this DFA we can see that Q2 is an unnecessary state because it's not reachable at all. So Q2 is unreachable and we can get rid of Q2 altogether. So we don't need this state in our DFA, so we can get rid of this and these two transitions. So that's the first step that we have in state minimization, get rid of all unreachable states. The next thing we want to look at is the actual state minimization where there aren't any unreachable states, because with unreachable states, state minimization is very simple. It's a very trivial operation. So the next thing we want to look at is a DFA like this. So let's say from Q0 I go to Q1 on 0, I go to Q2 on 1, and from Q1 I come back to Q0 on 1, and from Q2 as well I come back to Q0 on a 1, and I have a final state here which is my Q3, and from Q1 I go on a 0 to Q3, and from Q2 I go on a 0 to Q3, and Q3 let's say just retain state on both 0 and 1. So this is the DFA given to me, which has 4 states now. Now what we can see here is Q2 and Q1 right here and Q2 right here are both states from where we reach the final state on a 0 and we go back to Q0 on a 1. So we can say in a way that Q1 and Q2 are equivalent states. So we can get rid of these states. So the new DFA that I can draw after minimizing the DFA right here is a Q0 right here, which goes to a state which I'll call Q1, Q2. And this makes a transition on a 0 or a 1. And from Q1, Q2, I come back to Q0 on a 1. And I go to Q3 on a 0. So I have Q3 right here, and this stays on itself on 0 and 1. So now we have minimized the above DFA to another DFA with just 3 states. So this is the next step that we look at, which is if all transitions from some 2 states are take you to the same state, then we can say that those 2 states are equivalent and we can merge them into a single state. Now, one very important thing to remember here is that all of this changes if I make Q2 a final state. Now I cannot say that Q1 and Q2 are equivalent because one of them is a final state and one of them isn't. So that's one thing that we need to remember, because let's say we argue that we can make this a final state as well, but in that case from Q0 when I get a 0, in the above DFA I make this transition right here on a 0 to Q1, which is not a final state, whereas in the below DFA from Q0 I'm making this transition, which is to a final state Q1, Q2. So we can't do that here. So everything changes if one of them is a final state and the other one is not. If they are either both final states or they are both non-final states, then I can look at all of their transitions and say that if all the transitions are the same, then those two states are equivalent. So that's the second step in state minimization. Now let's look at another example right here. So I have a state Q0, and on 0 this goes to Q1, on 1 it goes to Q2. Now once again Q1 and Q2 both come back to Q0 on a 1, and Q1 on 0 goes to a state Q3, and Q2 on 0 goes to Q4. And now Q3 and Q4 both, let's say, retain state on 0, and they go to a final state which is Q5 on 1. Now in this case, when I'm doing the DFA minimization, I wouldn't say that Q1 and Q2 are equivalent because they are going on 0 to different states. But if I look at Q3 and Q4, I can see that they are equivalent because on 1 they go to Q5 and on 0 they just stay at their own state. So this again, we need to keep in mind that if on 0 they're not going to the same state exactly, but they're going to states which we are claiming to be equivalent. So all of their other transitions are to the same state, and one of the transitions could be, one or more transitions actually could be to themselves. Even in that case, I could say that they are equivalent states. So what I do is I have Q0 here, I go to Q1 on a 0, I go to Q2 on a 1, and from both of these I come back to Q0 on a 1. I'm just writing a single 1 here. I hope that's clear what's happening. And now I have a state which I call Q3, 4, let's say, and I go on a 0 from both Q1 and Q2 to Q3, Q4, and now from Q3, Q4 I retain state on a 0, and on 1 I go to my final state Q5. So I hope the self loop is intuitive enough that here as well I have these two self loops on 0, and here I have a single self loop on Q3, 4 which just goes to Q3, 4. So this is also a valid minimization. But now what's important is that in this case, in the DFA that I have at the bottom, which I got by minimizing the above DFA, here Q1 and Q2 have now started going to the same states on the same inputs. So on 1 they go to Q0, and on 0 they both go to Q3, 4. So now I can argue that Q1 and Q2 are equivalent states. So here I can draw my final minimized DFA, which is Q0 right here, which on 0 or 1 goes to a new state which is Q1, 2, which on 0 goes to Q3, 4, which on a 1, I think, yes, on a 1 it goes to Q5 right here. Sorry about that. So I have Q5 here, which is my final state, and from Q1, 2 on a 1 I go back here, and from Q3, 4 on 0 I stay at Q3, 4. So this is my final minimized DFA. So this is a scenario where state minimization intuitively has become slightly complicated, although not much. This is still pretty intuitive to see, but when the DFAs become bigger and bigger, it starts becoming complicated to do state minimization intuitively. But what I wanted to point out here is that once we do one state minimization, so once we claim two states to be equivalent, especially when doing this intuitively, we'll need to take a look at the resultant DFA again for further minimizations. So that's another point to keep in mind. But because this operation, doing it intuitively and iterating again and again over the resultant DFA, could become slightly complicated, we'll in the next video look at a more formal algorithm, a set of steps that we can perform to get a minimized DFA in one go. So I'll see you there.